In the previous video, we took a look at Alexis and Jenny on the number line, and we said that the distance from Alexis to Jenny is 5. And we represented this sentence using our absolute value symbol, where we had Alexis minus Jenny on the inside. We replaced Alexis and Jenny with their positions at -3 and 2, and then we found the positive difference, which is 5. That positive difference is our distance between them. Now we're going to put our detective caps back on and look for x. However, our clues for x are going to look a little bit different. For example, we might have something that looks like this. Now, what does this say? Well, just like with Alexis and Jenny, we can have a similar kind of interpretation. We can say that the distance from x to 3 is 4. And just like with Alexis and Jenny, we can color code this sentence. So let's go ahead and bring our number line back out and see if we can plot x and 3. Well, 3 is pretty easy. It's already on the number line. We have it right here. So what we're doing is essentially plotting Alexis and Jenny, but now it's x and 3. So what do we have here? What's our clue? The distance from x to 3 is 4. So we can say that x is 4 steps away from 3. So let's mark 4 steps away from 3. That brings us to 7. So x could be right here. The distance from x to 3 is 4. However, x could be on the other side of 3. So let's mark 4 steps on the other side. So x could be right there. So there's 2 spots that x could be using our clues. X could be -1, or x could be 7. Both of these spots on the number line are 4 steps away from 3. The distance from -1 to 3 is 4. The distance from 7 to 3 is 4. So both of these spots are where x could be. So let's go ahead and plug each of our solutions into our clues at the top and see if they make sense. We have an equation there, right? We have something equal to something else. So our answers of -1 or 7 should both satisfy that equation. In our first case, we have the distance from -1 to 3, and that would equal -1 minus 3 is -4, and our absolute value symbol looks inside and says, you gave me the negative difference. I wanted the positive. I wanted 4. And that's the correct answer. That satisfies our clue at the top. Let's check our second solution of x equals 7. So we'll have the distance from 7 to 3. So on the inside, 7 minus 3 is 4. And our absolute value symbol is happy. We have the positive difference on the inside. So the absolute value of 4 is 4. And that's what we wanted. That satisfies our clue at the top. So we started with our clues at the top and we made a sentence out of them. Once we had our sentence, we could draw a picture on our number line, which allowed us to quickly find x. So if you follow this step-by-step process in each of the problems, you'll find that your search for x goes pretty smoothly. So let's try another one. We have the distance from 2x to 5 is 3. So if x is a number in disguise, that means that 2 times x is a number in disguise. So this time we're looking for 2x, and then we'll break it down to figure out what x is. So let's bring out our number line. So we have the distance from 2x to 5 is 3. All right, we have 5 on the number line. The distance from 2x to 5 is 3. So we can go 3 steps out on each side. That means 2x is right here, or 2x is right here. So we have 2x equals 2, or 2x equals 8. And we divide by 2 on both sides, and we get x equals 1, or dividing by 2 again, we get x equals 4. When you first see our clue up here, it can look a little intimidating, right? You have 2x minus 5, you have 2 scary bars. What does this all mean? However, once you understand what an absolute value is, that is just trying to find the distance between two things, that you're just trying to plot 2x and 5 on the number line, it becomes a lot simpler. You're just looking for two things on a number line, and you're given the distance. That distance is 3, and that's all you need to know to figure out where they are. Let's try another. We have the distance from x to 6 is less than 3. This clue looks a little bit different, but let's see if we can think through it. So we can start off by marking 6 on our number line. Let's mark 3 steps in each direction. The distance from x to 6 is less than 3. So it's not equal to 3. It's somewhere less than 3. So x is somewhere in this region. Anywhere in this purple region, the distance from x to 6 would be less than 3. So another way to think about this is that we marked as far as x can go. So we started at 6 and we marked 3 steps in each direction. And that's as far as x can go. That's sort of like a boundary. This purple region says that x has to be greater than 3, and it also has to be less than 9. That's the region that it's contained in. That's that boundary. And another way to write this is x is between 3 and 9. So we were given our clue that the distance from x to 6 is less than 3. And we figured out that x could be anywhere between 3 and 9 and satisfy that clue. All right, let's try another. The absolute value of 4x plus 1 is greater than or equal to 5. What did I just say? I'm starting to sound like the fancy math folks. Let's take a step back. The absolute value sign is just there to remind us that we need to have a positive difference in the end. Well, to have a positive difference, you need a subtraction sign. So let's rewrite this to make a little bit more sense. So instead of 4x plus 1, we're going to have 4x minus negative 1. That's the same exact thing as above, but we're rewriting it so we can interpret it properly. All right, now we can say that the distance from 4x to negative 1 is greater than or equal to 5. So just by rewriting our clue in the proper form, we made it really straightforward. So let's bring out our number line. So negative 1, we can find that easily. And the distance from 4x to that point is greater than or equal to 5. Okay, let's go 5 steps in each direction. So the distance from 4x to negative 1, it could be equal to 5. So it could be right here, 5 steps away. Or it could be greater than 5. Same thing on the other side. 4x could be 5 steps away, or it could be greater than 5 steps away. So we have 4x is less than or equal to negative 6, or 4x is greater than or equal to 4. On the left side, we divide both sides by 4 to get x by itself, and we're left with x is less than or equal to negative 6 over 4. However, if you notice, we can simplify that. We can rewrite 6 as 2 times 3, and then we can rewrite 4 as 2 times 2. That allows us to cancel out some 2's. And we're left with x is less than or equal to negative 3 over 2. All right, that's one half of it. That's the left side. Looking at the right side, we can divide by 4 again on both sides, leaving us with x is greater than or equal to 1. So these are our two areas where x could be. We started off by finding where 4x could be. That's these two purple regions. And knowing that allowed us to simplify the problem and figure out where x could be. So x is less than or equal to negative 3 over 2, or x is greater than or equal to 1. So you can pick any x less than or equal to negative 3 halves, or greater than or equal to 1, and that will satisfy our initial clue. So with these absolute value problems, you want to make sure that they're in the correct form with a minus sign. Then you can turn these symbols into a sentence that describes the distance between two things. That sentence allows you to draw a picture of the number line. And once you have your picture on the number line, everything after that falls into place nicely.